Hello everyone. In this video we're going to be solving a nice rational equation. We have 1 over x plus 1 over x squared plus 1 over x cubed equals 14, and we're going to be solving for x values. I'll be presenting two methods and also show you some results towards the end. So let's start with the first method. For my first method, since this is a rational equation, how do I know it's a rational equation? Well, I made a common denominator and that just turned into a rational function. Okay, so let's go ahead and do that. Multiply this one by x squared, multiply this one by x, and multiply this one by 1. That gives us x squared plus x plus 1 divided by x cubed equals 14. Now here's one of the things that we're going to be looking at. If you set f of x equal to x squared plus x plus 1 over x cubed, then this just becomes a rational function. And rational functions have some interesting properties, certain things that we should be checking before we start graphing them. And why do we graph them? You'll see in a little bit why the graph is helpful. But let's go ahead and take a look at the solution method first. So if you just set f of x equal to 14, which is a horizontal line, in other words, we have another function g of x equals 14, which is a constant function, where they intersect, that's going to be our solutions. So we can go ahead and set this equal to 14 and try to find the x values from here. That's what the equation says, right? Well, obviously, x equals 0 is not a solution, so we can definitely easily exclude that. So making a common denominator is not going to hurt the solution, and also multiplying both sides by x cubed is not going to make a difference either, because we know x equals 0 doesn't satisfy the original equation. And that's going to come in handy in a little bit, but here we get x squared, and I could probably do the cross multiplication first because that's the highest power. 14x cubed equals x squared plus x plus 1. Whenever I see something like this, this is what I'm thinking. Probably because of all the cubics that I've been doing. I'm thinking about multiplying both sides by 3 and then adding x cubed to both sides and then turning this into a perfect cube. And of course you have to split the 1, because when you add to get 3 you just need to have 1 plus 2, in other words. Now, this is a perfect cube, and 43x cubed can also be written as a perfect cube, even though it's not going to be very nice. But this is what you're going to get. And this becomes a difference of 2 cubes, but I don't think that's going to be very helpful. I could be wrong, but I doubt it. So I tried it. This didn't work. I'm going to try something else. How can I solve this cubic equation if it's not anything special? Well, here's one thing you can do. First of all, put everything on the same side. So you get a complete cubic, and then you can try to solve it. If there are any rational solutions, they're basically going to be plus minus 1 divided by 1, which is plus minus 1, plus minus 1 divided by 2, plus minus 1 divided by 7, and finally plus minus 1 divided by 14. This is called rational root theorem. So those are candidates, and you can pretty much test them out, like, replace x with, 1/7, negative 1/14, and see if that becomes a solution. So let's go ahead and test 1. Obviously, 1 is not going to work because 14 minus 1 does not equal 0. So x equals 1 does not work. How about x equals negative 1? That doesn't work either. You can test it out easily, because with negative 1, the sum of the even coefficients should equal the odd coefficients, but that's not the case. So we're kind of done with these. And I don't think 14 is going to work either, because that's, 1 over 14. That's going to give us very small numbers. So I don't think that's going to work either. And 1/7 is probably not going to work. But think about it. Replace x with 1/7, you're going to get 1 over 343. And then from here, you're going to get 1 over 49, 1 over 7 minus 1. There's no way this is going to be 0, right? Obviously. Because if you divide by 7, it's going to be 49, and this is going to be 2. Could it? Okay, that's going to be like 2 over 49, 1 over 49, minus 1 over 7, minus 1. Obviously, this is not 0. So 1 over 7 is not going to work for the same reason, something similar, negative 1 over 7. So we kind of ended up with this. Obviously, if you use a calculator, that's going to be much faster. I don't know how much, but let's go ahead and test these out. How about 1/2? So I have 14x cubed minus x squared minus x minus 1 equals 0. I'm going to test out to see if x equals 1/2 is a solution. Let's find out. If you replace x with 1/2, it's going to be 14 times 1 over 8 minus 1 over 4 minus 1/2 minus 1. 14 over 8 is the same as 7 over 4 minus 1 over 4 is basically 6 over 4, which is 3/2. 3/2 minus 1/2 is 1. Are you serious? This is 0. Well, I knew that. But as you can see here, x equals 1/2 is definitely a solution. Great. We found the solution. So what do we do with that? We can do polynomial long division or whatever you want to do, synthetic division. Or you can basically manipulate this expression to get x equals 1/2. In other words, factor theorem tells us, hey, 2x minus 1 is going to be a factor. So here's what you can do. You can start with 14x cubed, and then to get 2x minus 1, you got to notice one thing here. These coefficients are in the 2-to-1 ratio, and there's a minus sign between them. So we got to maintain the same thing. At the same time, this is x to the first power, and this is multiplied by x to the power 0. So the difference between powers is also going to be 1, just like 3 and 2. But we got to play with the coefficients a little bit. 2-to-1 ratio, right? Remember that. So I have to follow up this up with 7x squared minus 7, of course. And then to get negative x squared, I got to add 6x squared. But that needs to be followed by 3x. And then that needs to be followed by 2x. And then minus 1 is going to do the trick. You see how I'm manipulating the expression? This is the same thing as long division or synthetic, but it's much faster, in my opinion. Anyway, so 7x squared, 2x minus 1. Take out 6x, 2x minus 1. I mean 3x, 2x minus 1. And take out 1, 2x minus 1. And this is just awesome because this gives us a linear factor and a quadratic factor. And quadratic can easily be solved. Set equal to 0. Use the quadratic formula. We do know that x equals 1/2 is going to come from here. And from here, we're going to get x equals negative b plus minus the square root of b squared. I have a feeling this is going to be complex. Minus 28. That's going to divide by 14. That's going to be a negative 19. So we can basically write the x as negative 3 plus minus the square root of 19i divided by 14. Do you think those solutions are going to work? Yes. Do you want to check them out? I don't. But you can definitely check them out if you want. But 1/2 definitely is going to work. Okay. So I kind of got towards the end, I think. But I still need to show you the second method. But here's one thing we can look at. The vertical asymptotes of this function, x equals 0, which is the y-axis, and the horizontal asymptote is going to be the x-axis. So the axes are going to be the asymptotes. Rational functions usually have asymptotes. Are there any x-intercepts? Something to think about. While you're thinking about that, I'm going to go ahead and erase some of this, and show you the second method real quick. Okay? Awesome. So we noticed that, yes, 1/2 is a solution because it works, right? I mean, there's no better reason. But how do we handle this in an easier way, sort of? Well, here's one thing. Since this equation was kind of given as 1 over something, 1 over something, 1 over something, we can definitely use substitution here. And this is how it works. Second method. We're going to set, let me go ahead and write the original problem one more time. 1 over x plus 1 over x squared plus 1 over x cubed is equal to 14. And then I'm going to do the following. Set this equal to y. And this is going to be y squared. And this is going to be y cubed. And then we're going to get a nicer, much nicer cubic, y cubed plus y squared plus y is equal to 14. And if you think about it, you're going to realize real quick that y equals 2 is going to work. Why? Because y equals 2 works, right? That's why. So then you can kind of do the following. Y cubed minus 8, y squared minus 4, and then y minus 2. Notice that negative 14 is going to come up on the left-hand side. And then you can factor. And from here, you're going to find the other solution. And y is 1 over x, so you just have to flip it to find the x values. Let me quickly show you the graph, and then we'll finish up with that. You can definitely do this, left as an exercise for you. All right, great. So those are the asymptotes. There are no x-intercepts because there's nothing that makes the numerator 0. Remember, the roots are complex in that sense. And here's the graph. This is a rational function. The asymptotes are, as you know, and it only intersects at this point. So the answer is x equals 1/2. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.